So we're going to start off by doing a little unsupervised learning first. We're going to use the k-means clustering and also hierarchical clustering, which are both unsupervised methods of machine learning, and k-means clustering, which we're going to do first. Basically, you're trying to assign each and every point to a cluster based on the nearest mean, right? So that's basically what k-means clustering is. And so to obtain the data, there's I think I mentioned yesterday that there's a whole slew of data sets that are included in the in the R program. And so if you ever want to see what data sets are available, you just type data and then parentheses. So today we're going to be using the iris data set. So there you are. And then if we want to see what the iris data set looks like, we just type iris. And so you can see here the iris data set. One moment. I was going to try to make the text a little bit larger, but are you able to see it pretty well, everyone? Okay, I guess so. All right, so in any case, you've got in the iris data set, you have 3 different species of irises: Setosa, versicolor, and virginica. And then you have several different kinds of measurements. So you've got the sepal length, the sepal width, the petal length, and the petal width. Okay, so we're gonna see if we can classify these observations or classify these into their correct species based on these observations. Okay, so the first thing we want to do is we want to grab the data from the data frame that we're interested in. So for us today, we're interested in sepal length and sepal and petal length in order to make these categorizations. So let's say grep is a function that is used to find patterns in strings. So we're going to use grep to grab any column in our data set that has the word length in it. Okay. Okay, and now we have a variable that contains so much information, right? Columns 1 through 3, 1 and 3 from our data set. So then we can put those into a variable called x, and we'll call it iris. Okay, and so this basically puts the columns 1 and 3 into a variable x. So if we look at x, you see that we have just the 2 columns of data that we're interested in. Okay. So now what we want to do is we want to run the k-means algorithm and then store the results in a variable that we're going to call CL. Okay. So CL and X, and then we want 3 clusters because we know that there's 3 different species that we've collected, and then n start equals 10, which is basically telling us to repeat this 10 times, okay? Or repeat the algorithm 10 times, okay? So now we'd run that. Now we can look at CL. And so this is just sort of the data from CL. So you've got the between sum of squares, and the total sum of squares, and then the percentage, okay? So we can then also plot these results. We'll tell it the column is cluster. Oh, sorry, column is equals CL, and then the column cluster. Not seeing it. I don't know what's going on with my graphics window today. I don't see it. Okay, well, in that case, I guess we'll just move on to snippets. Okay. Okay, so excuse me, I'm gonna rerun everything that I just wrote. I don't know what's going on with the graphic window today on my system, so. Oh. Okay. Oh. Okay, so as you can see, that's now separated into 3 clusters, okay? So now we're gonna try hierarchical clustering, okay? So because I'm on snippets, I'm just gonna go ahead and type all of this in. So. Day 4, and then H-clust is the algorithm that does the clustering, and then ACL, and then plot. Okay. Oh, got a parentheses. Sorry about that. Okay, so now you can see that the hierarchical clustering has his algorithm has been has worked. So now we see that there's multiple clusters, right? Now, if we wanted to obtain just 3 clusters, where would you want to put the cutoff? Does anyone want to guess based on this height here? And yes, Ajua?
We can only use one line, right?
Mm-hmm.
Okay.
Where would your cutoff be based on the height? If you wanted to obtain just 3 clusters.
I guess somewhere close in between 2 and 4, but closer to 4. I'm guessing that.
Yes, you're correct. So actually it would be 3.9. So we can test that. And run. So you can see here, that's the, you can add a line to basically show the cutoff. So you get 3 clusters, okay? You can also ask the program to basically cut the hierarchical clustering for you, such that you get 3 clusters. And so that basically is this function here. So cut tree HCL and then K equals 3. Okay. I mean, you're not going to see it because I didn't graph it, but that's another way. And then if you wanted to see if those two methods of cutting are identical, you type identical. And sorry. Oh, and then right, and then cut tree. Okay, and so you can see down here that we indeed prove that it is true that these two are identical. Okay, now we can compare the hierarchical clustering and the k-means methods for clustering to see which one is actually better. So we're going to set up a variable km, which is going to have our k-means. Okay. And then just to make it simple. Okay, so KM first for that, and then HCL, we'll say H clust. And okay, and then we'll make a table of KM and HCL cluster. And sorry. Where is it going? Okay, so we're gonna do that. Okay. I don't know, but this works, yes. I'm just gonna copy and paste. I'm sorry, you all. Okay, so now you see that there's a table here where you can check the k-means versus the HCl. But it would be better if we could actually check it across the data labels. So I'm actually going to skip down here to where it has the checking against data labels. So we'll put those there. And then I'm going to also plot the graphs for us to see. Okay. So okay, so based on this data, right? You've got your k means on the on the top here, right? And then your HCl on the side. Okay, and so you can see that you're there's some loss, right? In the second category, which is the versicolor. Okay, so so which one do we think is best in terms of versicolor? The k-means or the hierarchical clustering? Which one do we think is better?
Virginica?
So versicolor and virginica are where we're experiencing the losses. So hierarchical clustering gives us better virginica, right? I guess it just depends on which of these species we're most keen on having the best clustering for, I guess. So if we want to be biased towards virginica, then I guess we would want to use hierarchical clustering. If we want to be biased towards versicolor, then it would be k-means. Okay, so that is how to do some unsupervised machine learning using k-means and hierarchical clustering. And now we'll move to some supervised machine learning. I need a moment. I'll be right back. Okay. If you all have any questions, you can put them in the chat. I'll answer them when I get back. So I just wanted to show you that that it has the same exact structure as the original data set. So now I'm gonna go ahead and clear this. All right, so now we're gonna build the model. So we're gonna make a linear model of price. And we'll say we'll use our data, our training data. And so this is our model, our regression model. Okay, and so enter. Oh, sorry. Okay, and then we will make our predictions based on our testing of that model. So predict is the model that we created here, and then our testing data set. And then we'll get our results. Okay. All right, so then we want to C-bind, so basically we want to create the final data set. So we're going to C-bind or column bind the actual and the predicted price, which is going to be what we get based on our result regression. Okay, and then we'll call that final data. Okay, and then we want to make sure that's in a data frame, so we'll say as data frame. Okay, and then we want to get our error. So that's going to be our final data. Actual minus our final. Predicted. And then that will give us our error. And then we'll basically get our root mean squared error. And that's the final thing. So we want to C-bind again, final error. And then our root mean squared error. Let's see. Sorry, that's the final data error. And then squared. And then we'll get the error. Okay, and so now we have done a linear model, or we have a linear model of our data. So we can actually look at our final data. Oh, I didn't mean to do that. I should have just headed it. Sorry. That would have been better. Head. Okay, and so you can see we have our actual and our predicted price, and then the error. So the lower the error, the better. Yeah, so the lower the error, the better. But this is basically a very quick and dirty linear regression model. Does anyone have any questions? No? Okie dokie. I guess we can go into breakout rooms.
Yeah, great. Yeah, great. I think, yes, thank you, Raina, to provide this wonderful talk. So, and also Dr. Teng also put a link in the chat box. I think that's because I just briefly review that. So it covers many kind of the basic knowledge for the R. So I encourage everyone also check this link. Okay, so I will put into the different